Hello, is everybody wide awake? Everybody had a good time so far? So I've been moving lots of bits of data around for a long time. I've been at Roblox for almost 4 years now. Before that, I was moving billions of bits a second with specialty camera systems in feature film work for specialty cameras and broadcast sports. And now I'm here, moving lots of bits around in your games. Oh, there I am. So we're going to talk about what game networking does for your games. What is the group of engineers that I'm associated with, how do they help your games? And then what can you do in your games to take advantage of the features that we give to you? And actually, we're going to go over these things, communication, streaming, and then some deep under the hood things and some hints about how you can help your game. But a question I've had a number of times today has been, so what is this client-server model thing that we talk about? So I had them rearrange this room so we had two groups. Okay, no laugh, but that's okay. I want about this many people on this side of the room to raise your hand. You know, sort of, just raise your hand, this many. Yeah, perfect, okay, that's it. All right, leave your hands up, perfect. 5 people over there raised their hands. I'm the server, they're one client, you're the other client. It's a client-server model. Okay, I need about this many people on this side to raise their hands. 8 people on that side raised their hands. So all the communication comes from a client to the server and to the other clients. So that's my simple model, and I've been bumping my thing here, so sorry about that. Also, the networking is what makes us able to do really nice playing multiplayer games. Lets you do really nice playing multiplayer games. So instead of just one player exploring a community, I have a nephew that does Roblox Places, and he just does them for places to explore. One of these days, he's going to advance to doing multiplayer games. So what we do with networking is allow you to have these exciting multiplayer games. So again, to help explain what networking is all about, we internally represent your games in what we call a data model. You've probably heard this before. And it's the networking code, it's the networking technology that keeps this client's data model up to date with this client's data model, up to date with what my view of the world is, so that every player is seeing the same view, the same game. And it's our job to make that happen as nearly perfectly as possible. So we have this data model. It's a representation of your game. What happens? How does this change? Why do we care? Well, one of the things is that we have this cool physics engine. This cool physics engine will affect the game by applying forces of gravity, forces of acceleration, and that can change the way the data model looks. And that has to get to all the clients, all 100 clients, 200 clients. The scripts that you write in your game can change the data model. Oh, I'm changing this particular brick from red to green and maybe then to blue. I'm moving the brick on purpose. So there's things that your scripts will do to change. And I have to make sure that this client's changes and that it sees and this client's changes it sees are the same. Or the game won't feel good, it won't play well. The other thing that can change it is events can happen. Parts can collide with each other. Characters can change their animation because they've fallen down or run into something. And all of these things have to be matched so that all the clients are seeing the same thing. So you'll hear us talk about replication. I think in Giovanni's talk earlier, he talked a little bit about physics replication and replication. What we do is we replicate the state of the world. The server has its view, and for a lot of things, the server is authoritative. When you change the color of a brick from red to blue to green, The server is authoritative, so everybody will see it change red to blue and ultimately to green. Any other properties associated with objects, size, shape, texture, elasticity, anything like that might change the way it looks or plays or reacts is all guaranteed to be the same between all the clients that are attached. Now, physics is a little different. We would like to say that physics is also absolutely current. But, you know, if gravity is happening and this thing is falling down, if I don't get my communication to you that it's moved from here to here, then when it's moved down there, I no longer care about that. So if I miss that point, I don't care. I'll send the next one so that it'll continue to move down smoothly. If you did go to Giovanni's talk, he talked a little bit about interpolation, and that's what we do. So in case we did miss the point, we can make it move smoothly. I'll go on. Okay, so one of the things that's important to you, I would hope, is how do I make my game feel really great? And we are working very hard to give you the tools to make your game feel great. It will feel great if there is sufficient bandwidth to make all the communications that go back and forth. It will feel great if there's enough CPU power to execute your scripts. It will feel great if there's enough memory in the system to execute your scripts and do what you're asking the game to do. So we try to run the game at 60 frames a second. So hopefully every 60 times a second we run a little bit of your script and we do a whole bunch of work that we have to do. But one of the things that you can do to help it run better is be conscious of how much compute power it takes to run your scripts every frame. Because if it takes too long, we'll have to slow down. I'm sort of doing this backwards. Bandwidth, there's only so much bandwidth that we can afford to send between the clients and the servers and the clients and the clients to the servers. So be conscious of what you're expecting to change and whether there'll be enough bandwidth to make those updates. And we give you some tools to understand what's happening in these things, which I'll touch on in a second. Same thing with memory usage. Be careful of memory usage. We will, if you've got streaming enabled, which I'll touch on again in a second, we will start evicting parts from your games to make it fit in the device that you're running on. If you're running on a mobile device that doesn't have very much memory, maybe there's not too much of the game place that I can fit in. And so when you have streaming enabled turn on, that lets us make the determination that on that device, there isn't enough memory. Let's get rid of some of the stuff that this particular player isn't interacting with. And we'd love you to make big places. But be conscious that as the number of players go up in your place, there's going to be more work that has to be done for each one of those players. So that's, again, go back and look at the first three things and verify that you're not using up all the CPU horsepower. You're not using up all the memory. You're not using up all the bandwidth. So how many people went to the Pushing Physics to the Limit talk? Okay, I can say a little bit of it since I'll use a little bit of what Giovanni said. One of the things that we do to make the games play well is we make this massively parallel physics-solving supercomputer for every one of your games. We have the server, and then every one of your clients that attach to the server is another computer, and we distribute the physics load across all of them. And because of this, we can solve physics, a complex problem, as Giovanni talked about, much more efficiently. The other advantage of doing that is each client is simulating the physics around him, so that it's much more, that those things that are closest to him are much more responsive to him. So this is why the physics replication, which I mentioned in the earlier slide, becomes so important. We need to get the information from this group up to me, the server, and back out to this group, so that the things that were simulated here and the things that are simulated over here all look the same to each one of the players. So what are some tools that you can use to help improve your games? In your developer console, you can ask the system how much memory is being used on your client. You can ask the microprofiler, which is available to developers on their games, where CPU time is being sent. Another tool is you can ask the microprofiler to give you the CPU profile from the server. All of these are important tools, and you should be using them to make sure that, oh, by the way, there's a section in there that says how much time am I spending each step, each one of those 60 frames a second, how much time am I spending executing my scripts. And if we're running 60 frames a second, there's about 16 milliseconds worth of time that we have. We have a lot of work to do ourselves, and so maybe there's only 4 or 5 milliseconds of script time to execute your scripts. Take a look, see what it is. Because if those numbers are going to 40 or 50 or 60 milliseconds, guess what? The frame time's not going to be good. And I've seen a number of games that don't really need to take all that much time that do. So take a look, use the microprofiler, look at how much time your scripts are taking, figure out how to do it in less than 4 milliseconds. When you start building a game, look at this when you start. It's much easier to say, I'm not going to add this thing for every step than it is to say, all right, I have 20 milliseconds, how am I going to get to 4? So start early, looking to see how much time you're using. And this is an example of a microprofiler page, and Giovanni showed one earlier. But in this particular example, the orange bars that are across the top, I'll use my laser pointer here. Oh, I don't have one. The ones that are full are places where it's taken me more than 16 milliseconds to get through the work I have to do in that frame. Now, it might not be that that's a particular Lua script, but for whatever reason, whether it was bandwidth or whether it was CPU power that we needed to do physics, or whether it was CPU power we needed to execute your Lua scripts, something caused us to run over. And so be aware, use the tools. Okay, now I talked about streaming, now I'll really talk about it. So we have this feature that I hope everybody's heard about, but if not, hey, here it comes. We have this ability to only put into the game the number of, or the pieces that your player needs in the game to interact with the world. We've done this for 2 reasons. One reason is to help the memory impact on the client's device. If you're running on your desktop, you probably have enough memory. If you're running on a low-end phone, maybe you don't. But as the worlds get larger and larger and the places get much more interesting, the amount of memory consumed by the parts in the place can get huge. Streaming allows you to build places that you can't see in one machine. You can't see for one player. And this is what I said. So we only replicate the instances that the player needs. We stream in more of the parts around him as time goes on. We try to build a bigger place. But when the system runs out of, when the client's device runs out of memory, we start evicting parts to make sure we don't exceed the memory and crash because we have an out of memory condition. We've implemented a feature which is the minimum radius. So what's the minimum radius all about? You can specify as a developer what's the minimum amount of what's the minimum amount of area that I need in my game for the player to be able to play well. So there was a problem we had when we didn't have a minimum radius, is if I had a player walk to the end of the world, tried to take an extra step, I'd be disappointed. I'd fall off. If we have a minimum radius, we protect your players from that. So for some reason, because of bad bandwidth or anything like that, when I get to the end of the world, I'll stop until area comes in. So we have a way of protecting the players. We were working very hard, so it doesn't matter. But the minimum radius gives us a hint of what we have to work for. We also have the concept of a target radius, where you can say, this is as much of the world as any one player really needs to play the game. He doesn't need the whole world. He just needs this much area around him. That, again, is a hint to us. It lets us only put in the things that are required. And we will try to get all the parts into that target radius as much as we can. And as the player's moving around, we have to bring in more parts. We may or may not throw away the parts that we brought in before, again, based on how much memory there is. So what's coming? What's new? And a little bit of what's under the hood. Done that. Here's a little picture that talks about what we talked about at the beginning of the talk, which is how the communication happens. So we have various clients. All the communication is going through the server. And the only thing that really goes, there's a few other things, but primarily the only thing that will go from one client to another client is the physics. That physics that's generated by distributing the physics engine across the 100 machines that are attached if you have 100 players in the game. Other than that, events, properties, they tend to come down from the server to the clients. And one thing, we're always trying to come up with ways of reducing the amount of bandwidth that we need in communication. So, like I said, with physics, we won't bother resending if a packet gets lost because time's marched on, parts have moved. We don't want that old data. We want the new data. But if you've got a brick that's turning from red to green to blue, one of the promises that we make is we'll try to turn it from red to green to blue. But if we get a little bit behind, we may skip the green. And we'll go from red, we're a little late, we'll go right to blue. But we guarantee that whatever the last state is, that is what we'll get there. I think I'm being warned I'm out of time. No, okay. Okay, so what else? What's new? We've done some terrain LOD. You saw this in Adam's talk a little bit this morning when he showed the terrain and model LOD. For streaming, this is way cool because now what we say is, well, I get my minimum radius, which is like this little stage area here. But, when I look out, I don't see the rest of my world. Well, with terrain LOD, we're actually shipping a visual representation of much more of the world. So when I come into the game and I've got a streaming game, I'm not just sitting on this island of parts that's come in. I can see the world. And with the model LOD, I can see the objects. Somebody's got a big hotel in the distance, big building in the distance. I can see those, even though I haven't already used the bandwidth that's necessary to bring all those heavy data pieces in. I can see them. For streaming, we're looking forward to giving the developers more control, letting you have some information about, oh, guess what? Your player almost stepped off the end of the world. Instead of letting you find out because your player fell to the kill plane, we'll have some controls to let you be able to make some use of that. And that's the game pause mode that I have up there.